Welcome to the fourth video in our data engineering series. In this session, we'll dive into the engines that power modern data workflows, data processing frameworks. Data processing frameworks are the tools and platforms that enable engineers to handle and transform vast data sets. They automate and scale processes like cleaning, aggregating, and analyzing data, making them indispensable in any data engineering toolkit. Let's begin with the basics. Data processing typically occurs in two modes. Batch processing. This mode processes data in chunks, often on a schedule. For example, calculating daily sales totals at the end of each day. Stream processing. In contrast, stream processing handles data as it is generated. It's crucial for real-time scenarios like fraud detection or stock market analysis. A robust framework can handle either mode or both, depending on the use case. Some of the most popular frameworks include Apache Hadoop. One of the earliest frameworks, Hadoop processes large-scale data using a distributed approach. It uses the MapReduce programming model to split tasks across multiple nodes, enabling parallel processing. Apache Spark. Known for its speed, Spark processes data both in batches and streams. Its in-memory computation capabilities make it much faster than traditional frameworks like Hadoop. Apache Flink. This framework specializes in stream processing, offering low latency and high fault tolerance. It's often used for real-time analytics. Google Dataflow, a fully managed cloud service for batch and stream processing. It supports Apache Beam, a unified programming model for data workflows. But how do these frameworks fit into real-world workflows? Let's break it down. Imagine a retail company analyzing sales data. Batch processing might be used to generate weekly sales reports, while stream processing detects fraud in real time by analyzing credit card transactions. Frameworks like Spark and Flink are designed to handle massive data volumes, making them ideal for enterprise-scale operations. They integrate seamlessly with storage systems, orchestration tools, and visualization platforms to create end-to-end data pipelines. Another critical feature of these frameworks is fault tolerance. In distributed systems, failures are inevitable. Frameworks like Spark and Flink automatically recover lost data and retry failed tasks, ensuring reliability. These frameworks also support a wide range of programming languages, including Python, Java, and Scala. This flexibility allows engineers to work in the language they're most comfortable with, reducing development time. While these frameworks are powerful, they come with challenges. Engineers must carefully design workflows to optimize resource usage and avoid bottlenecks. Monitoring tools like Prometheus and Grafana help ensure pipeline health and performance. In conclusion, data processing frameworks are the engines that power modern data workflows. They handle everything from simple aggregations to complex transformations, enabling businesses to extract maximum value from their data. In the next video, we'll tie it all together by exploring real-world use cases of data engineering. Thank you for watching. If you found this video helpful, don't forget to like, share, and subscribe for more insights into cutting-edge development tools. Meta Design Solutions is here to help. Reach out to us at this email ID. See you in the next video.